Hey again, it's Mrs. Wethy for Lesson 2 on ionic bond formation. Basically, there are 3 steps in the process of forming ionic bonds. Now, they don't happen step by step by step. This is a simultaneous process, but for our sakes, we're going to describe it in 3 steps. So the first step is the formation of the positive ion, formation of the negative ion, and then the formation of the ionic bond. And that is when the positive and the negative ions are attracting and coming together to form that particular ionic compound. So let's take a look at an example between sodium and fluorine. First thing that you have to do is to write the electron dot notation for your element. So sodium has 1 electron in its electron dot notation, and how do we know that? Because it's in group 1. Group 1 elements has 1 valence electron. We're going to add that to a fluorine, and fluorine in group 17 has 7 valence electrons. Now, sodium's going to lose its electron, fluorine is going to gain it, so that they can both achieve a stable noble gas configuration. And that's exactly what happens. Sodium loses its electron, fluorine will gain it. So we're going to show that sodium has a positive charge, that is our positive ion formation. Fluorine will get a negative charge, and we're going to put fluorine in brackets so we can show that it has a complete octet and put its -1 charge outside. So the attraction between the positive and negative ions that forms in this process is the ionic bond. And we show that by writing a formula unit. Formula unit basically is the chemical formula for that ionic compound. But the definition for it is the smallest whole number ratio between the cations and the anions in the ionic compound. And it's just written like this. So sodium, we're not going to put a subscript because we are showing that there is only 1 sodium ion that was formed for every 1 fluorine ion. And that is the formula unit, or the chemical formula for an ionic compound between sodium and fluorine. Let's take a look at another example. Magnesium and bromine. Magnesium has 2 valence electrons, it's in group 2. And we're going to add that to bromine, which is in group 17, just like fluorine with 7 valence electrons. So magnesium wants to lose its 2, but bromine can only gain 1. So let's show bromine gaining 1 electron. Alright, so magnesium still has 1 to lose. So what we have to do is add another bromine, just like this, and show that magnesium loses its 2nd valence. It has to. If it doesn't, it will be highly, highly unstable. So it loses its 2nd electron to the 2nd bromine atom. So what we show then is magnesium has a positive 2 charge, forming the positive ion. And then we show that bromine has gained that 1 electron for a complete octet. We're going to put bromine in brackets just like we did with fluorine and put the charge outside. The only exception here is that 2 bromine ions were formed, so we need to put a coefficient of 2 in front of the bromine ion to show that 2 were formed in this process. The formula unit, we have 1 magnesium, and we have to show that we had 2 bromine ions that were formed, and so we show that by writing a subscript 2 right after the bromine. So the coefficient in the equation becomes the subscript in the formula unit. Let's take a look at one more. This one is a little bit more complicated, between aluminum and oxygen. First, write aluminum with its valence electrons, and aluminum is in group 13, so it has 3 valence electrons. We're going to put those in there, and then we're going to add an oxygen. Oxygen is in group 16, so it will have 6 valence electrons. So aluminum can lose 3, oxygen can only gain 2. So let's show that. There goes the 1 electron for aluminum and a 2nd electron, but it has a 3rd electron that it has to lose. So we must add another oxygen, because oxygen will gain, aluminum has to lose. So aluminum will lose its third electron to that second oxygen. But we see that oxygen has one more electron that it needs to gain in order to complete its octet. So we're going to add another aluminum, since aluminum is the metal and is the only one that will lose its electrons. So aluminum will lose one electron to the oxygen, but that second aluminum now has two more electrons that it has to lose. So now we have to add another oxygen. And once we add that oxygen, the aluminum can lose both of its electrons, the oxygen gains both of them, and now everything is satisfied. So we're going to show that aluminum now has a positive 3 charge, but we formed 2 aluminum ions in the process, and we had oxygen completing its octet. We're going to put that in brackets and a negative 2 charge outside, but we formed 3 oxygen ions in the process. The formula unit, we have aluminum, and there were 2 of them that were formed, and oxygen with 3. Okay, that completes our second lesson. So Brent, this is for you. This is P. Weethy 2 Ratchet signing off with Swiggity Swooty, I'm coming for that booty. Until next time.